So first recording of the year. We'll do this sometimes, just depending on how the lessons flow and all that, but I'm not going to be recording lessons while we're doing them live in the classroom, okay? So this is just an introduction, but I want to talk to you about the square root function, which I'm actually going to call the radical function, okay, or the square root function. When you graph it, it almost looks like a half U, kind of on its side, where if I went like this, okay? But you'll notice, and this is called the parent function, by the way. A parent function is the idea that any type of function that you have tells you the shape. So if I have y equals x squared, that's a parent function. But as soon as I go plus 3, it's not a parent function anymore. If I have y equals 1 over x, that's the parent function. But as soon as I put a 7 here, it's not the parent function anymore. Y equals x, that's the parent function. But if I put 1/2 x plus 7, that is not the parent function. Okay? So this whole year, we're going to be learning about different types of functions, and everything will all be based on the parent. So when you graph this, and you know it's going to look like this, but it's going to be somewhere on the graph, I want to introduce Desmos to you, so I encourage you to download this app on your phone. I know that you have access to a calculator, but this calculator in my mind is a lot better, and it's more convenient for what we're going to be doing. So I wanted to live do this with you so that you could see y equals, and then there's the square root, x minus 1. Then now, notice how you're in the square root. You have to get out of it by either pressing the right or just using that, and then plus 3. Now, if you look, it moved. I want to show you some cool things, so I can press that, and then look, there's 1, 3. Interesting, 1, 3. I want to show you some other cool things, which I will show you again, and I encourage you to be doing this yourself, by the way, is I created a table, so I went to that, and then there was a table option. Now, let's say if I wanted to know the value 7, it gives me the decimal approximation. If I want to know 20, it gives me the decimal approximation. If I want to know negative, oops, that's not what I wanted. If I wanted to know negative 14, notice how it says undefined, because negative 14 is way over here. We're not having an x value until we start with the number 1. That's the start when we're dealing with domain and range, okay? So I guess we can say if we're dealing with shape, well, it looks something like that, okay? It's opening up. Opening down would look like this, okay? The x-intercept is where it crosses the x-axis. So if you look, that's the nice thing about having it on your phone. You can move it around. You can also do this on your computer, is there is no x-intercept, so there are none. The y-intercept, it's not crossing the y-axis either. Now some of you go, well, how come that is? If I plug in 0, 0 minus 1 is negative 1. You cannot take the square root of negative 1. Okay. The domain. Well, the domain is based on where you start and then go to the right. So I'll put it in set notation first. X is greater than or equal to 1. Remember, smallest to biggest. That means 1 positive infinity because it's going to the right. Let me zoom that out a little bit. And then the range. The range is the y value. Well, it starts here and goes up slowly, but it happens. So that means y is greater than or equal to, what's that value? 3. So 3 positive infinity. It is a function and it is continuous because the line keeps going. Okay? It is increasing. This is just an introduction. I just want you to get used to how to describe functions, okay? It is increasing from, and wait, when we're dealing with increasing and decreasing, we're only focused on the x values, okay? So it's increasing from 1 all the way forever and ever. So it's an interval, so it's from 1 to positive infinity. And some of you go, but Ms. Rifkin, you went kind of fast. It's just kind of getting an introduction. It's not going to be in depth. We'll go into that later. Decreasing. Well, if I look, it just keeps going up and up and up and up. So there is no place on the graph where it is decreasing. the endpoints. Well, the endpoint is right here at 1, 3. And is that endpoint a minimum or a maximum? Maximum means the highest point, and minimum means the lowest. Okay? So if you look, that is the lowest point, and it is at 1, 3. Now, let's do a table. Well, I could just copy here, but I don't want to do that. So what value do you think I'd start with? Yeah, the starting point. Now, if I did not have my cell phone and I have to move that out of the way and I have to create more points, what value comes after x? I mean, after 1, 2. So I'd plug in 2. 2 minus 1 is 1. The square root of 1 is 1, plus 3 is 4. And then some people go, I know, well, now we'll try 3. Well, how come I wouldn't pick 3? Well, because 3 minus 1 is 2. I cannot take the square root of 2. So what would be the next whole number that I could use in order to get this to be a whole number? So when I think about that, I think of square roots. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3, ... So I figured out that the square root of 1 gave me 1, plus 3 was 4, so that one's done. So that means I need to try to get a 4 from this. So that means that x would be 5. Because 5 minus 1 is 4. So 5 minus 1 is 4. The square root of 4 is 2, plus 3 is 5. Now this time I want to try to get 9. So what does this have to be in order to get me a 9? 10. 10 minus 1 is 9. The square root of 9 is 3, plus 3 is 6. What comes after that? Square root of 16 is going to give you 4. Does anybody know, based on the pattern, what number should be next? Well, let's find out. So how could I get 16? 17. 17 minus 1 is 16. The square root of 16 is 4, plus 3 is 7. Okay, we get it. And now let's just graph it. 1, 1, 2, 3, 2, 4, 5, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and then it's a half U forever. Okay. The asymptotes, we're not even going to worry about that right now. Okay. All right, let's look at the second equation. Now, I'm going to go back to my graph on Desmos. And I'm going to go graph this one. So I'm going to go y equals negative square root x plus 2. I want you to predict what you think the starting point would be before I finish. And then see if you got it right. Remember, I have to get out of there, so I have to press the right, or I have to go like that, plus 1. So let's look. Oh, wait a minute, something happened. I didn't press the starting point. Let's try this again. I'm not very good at it. There we go. So, oops, it's very sensitive. If you see, it's negative 2, 1. Interesting. Okay, so we know the shape. So remember we talked about this one opens up, this one opens down. I'm hoping some of you see why this one's up and this one's down. It's based on what is in front. If this is positive, it's up. If this is negative, it's down. You'll get good at this. X-intercept. Oh, this time there is an x. Is there an x-intercept? Yes. Negative 1, 0. So there is an x-intercept. And again, I encourage you to do this yourself. You're going to be using these types of things to help you. The y-intercept, what's nice is I can touch right there. 0, negative 0.414. The domain. Okay, domain is everything to the left, everything to the right. It starts this way, and don't say goes down. Say goes to the right, because domain is right. So that means x is greater than or equal to negative 2. Negative 2, positive, positive infinity. And now the range. Okay, I got too many points happening here. Let me see if I can make those go away. It's not wanting to give me that one. Now the y is the range. So the problem is the y is everything up and everything's down, so it's going down. Remember, smallest to biggest. Okay, let me look at time here. Okay, we're good. It is a function. It's continuous because the line keeps going. Increasing. Well, when I look here, remember increasing and decreasing has to do with your x. So as you go to the right, is this graph going up or down? It's only going down, so there is no place where it's increasing, but it is decreasing. Now remember, it's always based on the x, from -2 all the way to positive infinity. Some of you go, but it's going down. No, when we're dealing with increasing and decreasing, we're dealing only with the x conversation. Endpoints, well, we started at -2, 1. Is this a max or a min? Well, it's the top point, so that'd be a max. I don't care about the asymptote. All right, let's graph it. What would be the first point? The point that we started with, -2, 1. So now, what if I try -3? If I try -3, -3 plus 2 is -1. And some of you go, and a negative make a positive. You cannot make those positive. Those are different things. They're in different places. The square root is blocking it. But I can do -1. -1 plus 2 is 1. The square root of 1 is 1. And then I have that -1 plus 1, 0. And then some of you go, I know, let's try 0. Well, remember, 0 plus 2 is 2. You can't take the square root of 2. But that's what ended up the y-intercept, and that's why it was a decimal. So we go back to this idea of what we did previously. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. So what I want to happen is I already got this 1 to work. So what number plus 2 gives me 1? -1. Now, what number plus 2 gives me 4? 2. And some of you go, Miss Rifkin, I don't understand what you did. Let me give you an example. What number plus 2 equals 4? That's like x, isn't it? -2 minus 2, x equals 2. That's what solving really means. What value will give you that? Okay. So 2 plus 2 is 4. The square root of 4 is 2, but it's -2 plus 1 is -1. Hopefully you're seeing the pattern here. What number would come next? -2. So let's see if we can get it. What value, when you add it to 2, is going to give you 9? What value, when you add it to 2, gives you 9? That's x. So 7. 7 plus 2 is 9. The square root of 9 is 3. -3 plus 1 is -2. Which means what goes here? -3. Let's do the 16. So how are we going to get 16? 14. 14 plus 2, 16. Square root of 16 is 4. -4 plus 1, 3, ... You get it. Let's graph it. Left 2, up 1. Left 1, 0. 2, -1. 7, whatever, -2. And there we go, forever. Okay, this thing only goes to 15 minutes, so I want to make sure I address homework. So let me do that right now, and then hopefully we'll make it to there. So what I want you to do is, based on these parameters, I want you to draw a sample of what this could look like. Based on these parameters, I want you to draw the same thing. Okay. In this one, they want an equation, a little hint. It should be like a y equals mx plus b equation, where the m represents the pattern. What's the thing that happens again and again and again? And then how much did you start with? Okay? This is a little difficult, so I will do one of them. I'll do letter C. So I want you to take the 0.01 and plug it in. So 1 over 0.01. Yes, you could pick up your calculator, but I'm going to show you a different way. This means 1/100ths. So it's really 1 divided by 1/100ths. Let me rewrite that. 1 divided by 1/100ths. Remember, when you're dividing, it's the same as multiplying by the reciprocal. So 1 times 100 is 100. Okay? You can always use your calculator, but I want you to know how to do these things without it, because you're not always going to have access. Okay, this one, input-output machine. This one is factoring. So this is maybe when you learned how to do the box, or a different way. Okay, this is more factoring, and we might end up having to go over it if you need help with it. And that's your homework.